least add this variable now. Seaweed user ID 1001. And I believe we want this as a string. Now let's scroll back down. I just read the headers. So, running executable with increasing size arguments, generating non-repeating string, running executable R2 with generated string, finding AP position using R2, output of crash address, and then where we're modifying stuff. Generating shellcode for Seaweed binary for set user ID. Not this one. And it is a string, meaning the variable that I just created is a number, which is a logical thing to do, right? So let's convert it to a string. Let's make people add the variable value as that and convert it to a string. So here we do str and the variable name. So it will make this the right thing. So we want to keep this. If we want to see the assembler code, we can do that. But this is really finished, this part of it, so I just thought of something to make it better. Then we're testing for bad characters, and this is what we've been doing lately. And when we run test for bad characters, we send the bad characters in our buffer overflow string, and we want to make sure that the string is not like aborted at some place, or some character is not read into memory as it should. And when we read this from memory again and check, we might get like a lot of diff between our different data here. So I'm not sure exactly this bit of my code was ChatGPT generated, and I'm thinking that maybe I do want to do this manually in a very obvious and clear to read loop, instead of using one of these not very readable, let's see, where is it? Here. These are not extremely readable, right? So hex the byte for byte in use chars. So we're going through our use chars here, and we check if it is in stack data, but we're not checking the position of it.
All the code that you are using.
Yeah, I do, but it is not finished yet. And it is not updated on my Git repo. But if you go to do exclamation, I can do it here, exclamation GitHub, and you go to my Obsidian public repo, you will have this soon, but it's not finished yet. So all of my stuff is there. If it's not a specific bit that has its own repo, then it's another one. I think there's 4 parts of my nodes that are actually separate repos in there. So we're going to make this a loop, because if we detect one bad character, a character that cannot be inputted into memory in a good way, we don't want to just assume that this is the only one or the last one. We want to loop, we want to just do the first one and skip the rest of the stuff. And then we want to loop. So this is one reason why we're gonna make this new code better. So this is also like, I might make functions of these, you know, make it prettier code, but right now we're just exploring pwntools, and I marked off the sections here of the different steps of what we do when we make a, well, automated shellcode generation for, or the input string that we need to get the buffer overflow on the server running this. So, in this case, we have the F letter from reading the source code. So it is a specific case. So it doesn't matter for this. And we're also adding null there, as this is text input to a C program, right? And null terminates a string, so I'm assuming it wouldn't work. Yeah, so I did a comment here saying loop here, right? Here it is. So we want to change the value of the bad chars, or really we want to add to it. Let's do move the bad chars up, and let's make a comment here saying initial bad chars null, and possible characters so I'm thinking like from source code, how will I formulate this the best? Characters from reading the code, the program's code, and then if it's assembler, or we made the C code with Ghidra. So here we're gonna make the loop. Do we want a for loop? We can exit out of it. We do have a maximum like length here, so we can make it a for loop. Let's do that to start with. So also all chars are, that's all characters. And this bad characters is the initial bad characters, right? Then when we loop, we're going to update this use characters here. Actually, let's make the byte conversion on this line, because it's not a complicated thing. And I'm thinking saving a line here might be better for us than having it more easily read in another way. So this is what I don't like about code. I'm just moving the mouse or the cursor, and suddenly stuff just hops up, right? So now we're converting it to bytes on the same line. I think this is still not what everybody would want to read, right? This bit. So let it be needing an explanation. Remove bad chars from all chars. And convert to bytes, because that's what we want as input later. And this is if we want to print the whole thing. Let's add a comment, debug print. So, assuming we have a new bad chars here, we do this for the new value in the new loop. We can do the colon at least. But we want to do this for, I guess for, yeah, I'm not sure what I want to do. Maybe for the length of all chars, which is always 256. So that's another thing to do. We can do it. Yeah, I'm leaning towards not having a 4. That's what I'm doing. I'm thinking, do I need an index somewhere? I don't think so. Let's just do a while through, and then we'll see if we need something. We'll change it. Yeah, cookies T. So use chars. Why do we have a squiggly? Oh, because it needs to be indented now. So all of this down to the exit here needs to be indented. So here I started writing like half set of code for what we need to do, but let's do one step at a time. So we first get our current use chars. The first time we use this as a bad chars, next time we will have an updated bad chars with a new character, right? We can print these use chars out. The characters to use for the trying to find the bad characters, right? So the characters to use rather with the bad chars removed from all characters. That's what we want. Then we have argument, a cyclic string, plus b times address length, meaning it will put 4 b's here. The cyclic string and this is just to make sure that we put the use characters after we have already generated our buffer overflow. If we didn't do this, it might not crash. It might not buffer overflow. I had this problem before. I just used this, and then it didn't buffer overflow, even if this was supposed to be long. But a character in the middle aborted the string and we didn't buffer overflow, and I was like, what happened? Right? So now I know better. So I'm just hoping that this string will fit at all. But that's, I guess, part of the test that we might have to account for in our loop here. Print argument. Yeah, so we just debug printing the argument. I guess I could have debug print to everything. Or we just skip these lines. And if we need them, we add them, because the code is much more readable without them, right? So, P, process, we can do this. These are the same. Do we have another one of these? Yeah, over here. Yeah, let's just redo that. We have another one if we... I don't have to remember the syntax. Hi, John.
Rosemary says.
Welcome back.
Hello.
How are you today? So, let's see. We're checking the length of use chars. Why do I want to know that, really? Because I was testing here. Yeah, so we don't need this anymore. So first we get the argument we're going to use.
Thanks.
Oh, great, wonderful. And then we're starting a process with the argument we just got. Then we wait until the program crashes. Really, because it will crash. Well, I guess I make comments now. Run the program with the argument. Not that complicated.
Are you programming hacking tools?
Yeah, you could say that. So we're using something called pwntools. So that's actually what someone has programmed more advanced. And we use this to to make an automatic buffer overflow generator for SUID Linux binaries that we happen to have in the CTF or something. So that's what we're doing. And this, of course, also makes us really go through and understand all the steps of the buffer overflow and the exploit generation. So this is very nice. Get data from the stack pointer for the length. Yeah, this is get data from the stack. From the stack to the length. Yes, so I don't know if this helps or makes it worse. From the core dump. Get the data from the SP stack pointer for length. Use chars characters. It was a bad comment. Now it's worse. Is it? So we have we want to get the stack data we're interested in here. What bit of the stack in the core dump do we want to get? We want to get from the stack pointer because the last thing that happened, what made the program crash, was that it popped the EIP from the stack, and when it did that, it was like, dude, I can't hop to BBBB. That's not an address I can use. What you doing? Crash! And then the stack pointer points to the next byte, which is what we just added here. After the address, we put our special characters that we want to check out. And we want to use the length of these to later compare with and step through. So we'll actually do another loop here. So there'll be loop and loop, and this time we're going to make it a for loop, I think. So now we have the stack data. Core file context of stack pointer position. So we're printing this data here. That's what we're doing. And this can be a good debug, right? Currently, as we're building this, we'll remove this later. So the data that we got here, stack data, this just prints it. And now we're going to check through this, and we're going to do it instead of the previous way. We're going to do it manually. And instead of new bad chars, we will just get one new bad char. Because if there is one mismatch, we want to add it to our bad characters, reset it all, and redo the check again with this character excluded to make sure that it doesn't corrupt several characters, because it does sometimes. So instead of this loop here, we're going to make a new one. Just confirm that the tab makes spaces. So for byte in stack data, and we'll step through all the bytes in stack data. No, I don't like this. For byte in use chars. Okay, they should be the same, but we're going to compare them. So let's do use chars here instead. And also I'm using underscores now for the other variables. Maybe we should do all underscore chars, bad underscore chars. Yeah. Let's just make the change. So Control H on this, and let's do all underscore chars. And replace all on this, all 3. And then we do the same with bad chars. Bad chars. It's a tiny bit more readable, right? It's not a lot. But bad chars we have in 11 places. So, and then we have use chars. The same thing. Use. Yeah, this is a question. Should we do it used chars? It's more like chars to use. We can call it chars to check instead. Chars to check. Right? These are not excluded already, being in bad chars. They are not all the characters. They are the characters to check. Let's do that. Making it a tiny bit more readable for every step, right? So now we're adding this and the characters to check. So now instead of just being use chars, it's, oh, the characters we're going to check. Okay, I get it. You know, it's more readable, isn't it?
Fixerbot says,
welcome in and thank
New
you for
follower
the follow.
cat bits. Less than 3.
So let's see here. So variable names, I think it's kind of important to have them readable. So you can read it just as Python is so readable too. You can just have it. So P is a process with our executable and its arguments. Okay, yeah. So if this had been called E or validate, which is the name of the executable, we would have been like, we're validating arg or something? What are you talking about? And then P wait, we put a little comment there. From the cordon, yeah, so next thing here, we get this data from the stack by reading the core file. And pwntools, we're not actually in our system making core files, which is a Linux functionality. But I'm assuming that pwntools changes these, when it runs the processor, it changes the settings in the environment so that the core file is generated and it's put in the local directory. So we have to watch out a bit when we do this because it makes a lot of files. So if we go to BAF, where I'm experimenting with this, and we check here, we're going to have a lot of core files because we've run the script several times. And you know, they can be big, so we're gonna have to remove them sometimes. So let's do that now. Sudo rm core star again. Wasn't the first time. We did this yesterday, I think. So there, now I only have the scripts. And the first ones I did with a pwn. I added pwn to the start, but now I'm thinking let's just assume we're using whatever stuff as usual, what we need, and call it what we want it to be. New bad chars. Yeah. Anyway. So, the reason it is squiggly was because there was no indentation, right? Let's xi1. So going back to where we were, we changed char to check name. We read from the core file the length of the characters we want to check. Is it the same in the memory as it is the ones we sent in? Was all the characters put in memory? And we're going to loop through it here and check. We could also like print them both and check it manually, but this is all about automating it. So for byte in chars to check, we're gonna compare if shards to check. Right. We want to compare both. Yeah, I'm thinking I don't want this. I want an actual loop of the length instead. So we're going to make it instead I, and let's do a range here. And we can do it on the length of this, I guess is what we'll do. So, sorry for the parenthesis mess there. So, we want to do a range of the length of the shards to check. And this will be right or not. We will have to start with printing all of the numbers and not have an exit, because yeah, I'm never sure of the range functionality. It's a bit odd. Some Python is a bit odd. Let's finish this one too. And here we actually want the position I of these instead. This is why I changed the sort of loop, kind of loop. We want a number. So let's print I. Let's actually, well, let's just print I, and let's actually print the length before the loop. I'm sorry. Copy, and we just print it here. So we will have the length, and then we will see what numbers it goes through. And we can also print this. Why not? So print. Let's do an F format to string, and let's do make this just print this data, and it will need to be converted from a byte to a string. So we do the same with this one. There. So now we're comparing the shard to check, character, printing the character with this. Or should we not do that? We'll see what it prints. And then I'm thinking we'll add an exit here. Our millionth exit in the program so far. There's like 2. Exit here. Not a million. Only 2. Cause the next stuff, this will need to be updated, you know. So now we're just printing the length. We're checking what indexes will it go through, and we'll see also if we can print these if they're available. We should have this length of data from in this stack data one, but it might not be, you know, the data we want. So it doesn't matter as long as it can print those, right? And it doesn't miss the last character. We'll see the index. So let's run it. Alright, I renamed it. So we'll have to actually get the new name. And that was me missing the keys. So /paste. So it's going for all the steps, and it ends on index 253 with 255 equals 255. So far we haven't found any bad characters here, so I might have to like add one to test this. But as we can see, it looks good, right? So it starts with index 0, where we have 1 equals 1, because we excluded null. Or it would have been 0 equals 0 here, right? And it got the digits, that's what I wanted it to do. With a string conversion from byte. I was thinking, do I have to make it an int and then make it a string? But it worked fine. And here the range is actually, the length is actually 254, going from 0 to 253. And it works with our variable length. If it had not, I'm scrolling and scrolling, we would have gotten an errors here too. But I know that the last one was 253, right? So from 256, we're removing 2 characters. So we have 254, the index being 0 to 253. So it is right, it's correct. Just wanted to confirm this before we do anything. And also, we got our confirmation that they were all okay. So let's just add a I'm gonna have to overwrite something, and we already have the way to do that here, right? So I'm making a bad data test, right? We want it to fail, and we're gonna change 35 to binary or byte, not binary. My brain says binary sometimes for B for some reason, which is not very hard to understand, but maybe. So let's make B. So this should be not a. We could do a number here, right? So 35 shouldn't be 53, just to make it easier to find, right? That's far enough apart. We'll see if it complains about the type here, because this is bytes. But I would assume that it would be able to do this conversion. But I might have to do bytes on it, or byte on it. Bytes. Or just do the B and put a random character there, because I don't remember what 53 is. What would it be? 41, 42, ABC. I don't care. Let's put something I know is what it is, right? So let's put an E there, and I know it won't error. And that's 41. So, what we want to add before we test this is an else. And this else will make us know there was an error. Let's add this out, but let's make something before. And these are now not equals. So I'm actually using the C version of saying that now. That wouldn't work in here, I think. We use not and then the double equals here usually. Yeah, that's what I do in Python at least. So error, bad data. So we should see this line stick out, but we're not doing anything special right now. We're not hopping out of the loop, which we'll do later. And let me running this again. It is doing all the steps, generating the code. Byte object doesn't support item assignment. Okay, I didn't know that. So this is a perfect ChatGPT moment. So let's see if I used my ChatGPT for today by making a CV. I actually compared today. I asked ChatGPT and I asked DeepSeek to do the same thing. Make me a CV for this job, but this is my old CV, right? And some other data. Actually, my LinkedIn about text, only that. And both, they just gave me skills I don't have, right? They added all the things from the job. So I didn't have all the things from the job thingy. So let's paste this here. And I'll skip this. You're getting rid of typo before byte objects are immutable, meaning you can't modify their content directly. Fixes stack data, converts stack data to a byte array. Oh, and then I can do it. Sure, that's a quick solution, and I would never have guessed, right? Or B, A0. Okay, so B A0. That's interesting. Because it needs to be an array. Let's skip that. It's not always right. Alternatively, you need an immutable solution. Create a modified copy. C data, stack data equals stack data. B stack data. Oh, this is prettier. I like this. It's so smart and simple. And I know already that it will work. I think already that it will work. Right. So let's add this instead. So instead, we're just getting the data before this and the data after this, and we're putting the A in there. So we're creating a whole new stack data from stack data before what we want to change and after what we want to change. Very, very nice and logical. And I'm sorry if I'm mumbling constantly, right? So now we're gonna run it again and see if it works better. And it did. And we're going to scroll up. And I should have put it at the end of the data. So here we have it. Error bad data. And it converts this character. I don't know why it does. So we found our error bad data here. So if this would have been a bad character, we would have found it. And it is on 35, which is the one we modified. And 36 is not 65. 65. Now I'm curious why it ended up 65. I should have done this, right? Oh, because 42 is 41 is obviously not decimal, right? It's 42, it's not 42. So that's why 41 in hex is 6, 5 base 10. So that's why. Those numbers are like stuck in my brain forever now. So we don't have to output it all anymore. We just wanna find the error, right? We introduce the error, but we still wanna see it. We don't have to print all the lines. we don't have to print all of these. Actually, we don't even want to see these. We'll remove the else and instead we'll put a not here, right? So now we found our error without printing something for the other ones. We confirm that it works. So we only got our error there. We're still printing the length. Let's remove it. Length here. So, yeah. So what we want to do now is save this data. The bad character. So print. Now let's do another F, I guess. Word, what's what they use there? How do I make a byte a character again? We don't want that. We want the number, but we want it in hex. So maybe we should use this syntax instead here. So we use it in several places. I'm just gonna copy something. Here, there we print a hex value. So, and this time what we want to print is, well, this really, because this is a bad character. This is the wrong character. That's a reason for this. So, and this is the new bad character that we have added manually though, but still, right? And test run. Error by data 36 is not 65, and 36 in hex. Let's just get the calculator up. And let's use, this is a scientific one, but I think there's a better one. The programmer one, that's what we want. We can see all the things, so we just do 36 here. We will see that in hex it is 24, or 24. So 24 B16 is 65. So we have the correct bad character here, and we would add this to our list of bad characters, and we're actually going to do it, right? But what we need to change first is this line with introducing the error. It will keep introducing this error, right? For every loop lap. Well, it won't. It does it before. No, it will, because this is the loop I'm talking about now. The big one. So we need to do this introduction of the bad data into stack data. So we can instead change the shards to check instead. But it would still be wrong because it's still calculated at the same place. So to make this possible, we can make an if here. So if chars. Hi, thank you for the follow.
New followers
Welcome
on the
in.
girl. Less than 3.
Yeah, so how do I introduce this only when in the right place? Our fake error. We don't want it to be repeated. So let's make the code, and maybe it becomes visible where
says.
to put it.
I had to send Zoms over here. She's just getting into this nerdy stuff.
Okay. Thanks, Penna. We always want new, fun people in there. So, very welcome in. Extra welcome in. Zombie girl. Yeah, so what we're gonna do here is to hop out of the loop, as we're going to do a break here. But before this, we want to save the character to our bed cars. So instead of what we had below here, new bed cars, we're gonna delete this. And we're gonna make it new bed char because we only get one. We only take one now. And it is... we actually don't even do that because we're just gonna add to our bad chars here. So bad chars is used when we generate this, and it is a normal string. So we're going to do bad chars plus equals, and we're going to add our new character. But I need to print it first because I need to get it in the correct format, and I can't do this to put it into a variable. So I need to make a conversion really manually. So maybe this is not the best way. What if we just add it here? And then we print bed charts. I think this will break. So, yeah, if we just print it like that, it will do it. I'm curious now. Did I? Yeah, I broke it here. So we do have an infinite loop here, but we're exiting still, so it doesn't matter. It will still just do one lap. It's not fun to have a infinite loop going, right? And control. Yeah, so can only concatenate string, not int to string. So we need to make this a string, but I don't think this is the right way, because when we use string to convert the byte, we got the number, right? And we don't want the number of the byte. We want the character, meaning it kind of solved itself there, right? Because we want to convert it to a character. So let's do that instead. So is it char it's called? I kind of think so. We'll see. So this is the logic of Python. Char is not defined. Yeah, so what is it called? Sure. So the dollar character, is that what it is? Yeah. So we got a printable character. This means I want to print bad cars again, but I want to do it in a pretty printed way. And we... I killed that information before, so I'm gonna open my notes because I have my old script from yesterday put in the notes. So Finding bad characters. No. Alright, it's closed. Have to fix it. Here, I should have. Oh, I have this up too. It was just further down. So I'm just gonna steal my own code here. One of these. And let's print it this way instead. So new name, and then we're gonna run it. So unknown format X for object of type string. Oh, it's a string, right, we don't. Right. We'll just add a byte here, because that's what we want. And we will need to also add the... I guess I should learn this in my brain. The name is... No, it should be here. I'm too far up. It's within the same section. Latin 1. Latin -1. So every time you type it, it will be more in the brain and not in the, or even in the fingers, right? So now we can see that we have null, 4-6, and 2-4. So 2-4 is correctly added as a new bad character. This is just what I wanted to see. And let's add here a current bad character list, and this would go kind of quickly, right? So we might not want this if we get a lot of ones, but it might be nice to still see it working through the data, and that it works, instead of just getting a list and you're like, this is correct, I don't know, what did it do? I don't trust this. So we get the new bad characters. We add it to the bad characters that we actually use when generating this up here. And then, and now I have an if, right? So if the length of the bytes is more than 3, we don't want this done, right? If my brain is mixing languages. If the length of, let's just type it, it's not that long to type, bad chars is more than 2, then it's less than 3. If it's less than 3, then we're going to fake a bad character. But if we already added the character, then... So you see, when we did this, we got the automatic easy solution for this, right? So if you're like, oh my god, how am I going to check for this? Just do the rest you were half done with first, right? So, we have one character. Now we can remove our exit here. And compare expected vs actual data. This is what we do here. compare the expected and the actual data. And maybe we should keep this comment. This is my like pseudocode here for this. Compare expected versus actual data. And we don't need to print this because that was old. If not, then the first of the new badges. Yeah, so this was before we added the loop. Now we have added the loop. So now it will instead exit before the next section. And here we have a fake bad characters statement. And we can move this. We don't need the fake anymore. We're actually doing it. So that was just to test the output before we edit anything here in this section. So I think we're probably done. We have to test it, and I'm going to put an else here and add some other data. So else, let's do an elif, and we're gonna do the same but add another character. So we add a new one, another fake, and this is actually on top of this instead, because this whole section is just a test. We're going to make another bad character here, which will be something else. So let's do 75 instead, and 76, and let's add an A, because I don't think that's the right character there either. So we have we're adding if it is less than 3 characters. Oh, we need to change 4. If it is less than 3 characters, always go through and check the logic. Less than 3 characters, we add this. Next time, when the new bad character added, it is not less than 3, it is actually equals to 3. So then we go to the else if. If it is less than 4, then we add another bad character at another position, at a totally different place. Then we go and do this, add it. So now we have 4 characters. We go back in. If it is less than 3, no, it is currently 5 or 4. It's currently 4. No, is it less than 4? No. So it's not adding any more bad character, and we should be finished with 4 characters at this. So let's test run our script. So testing for bad characters. So we're printing a lot of data here. So maybe we shouldn't do that. And it's also not stopping. Yeah. We have an infinite loop and we're not breaking out of the loop. No, we're not supposed to break out of the loop. We're just not supposed to output stuff. So let's go in here and not print this whole darn list. That's mega long, right? So where is the print? Here. This is a debug print for development, and we don't want it anymore. And now let's see if this is actually finished. It's still going. Yeah, so I have a logic bug. How did I think? So we have a while true here. It needs to exit this one too. So we need some kind of condition on when it is finished. So when this actually reaches
TV says,
the end
hello,
here.
fix it.
Hi! Welcome in. So, Hope everything is good with you. I'm gonna see if I can put another thing here. So, if these are equals, if these are the same, it will break this loop here. And then it goes to the next one. The next character. No, it doesn't. Why are we looping here? Because we're updating the bytes. And if we compare, if we look at the data here at the start, so it kind of went a few laps in the loop. So first here, error bad data, it found this. It found our other bit of bad data. And then it's just keep going, and it's not finding anything more bad, right? And at this point, when it's found the second bad data, we don't know yet that it's finished. But here, when we loop through this, if we reach the end, so let's do an else to this. So this is when I prefer having functions, right? Because then it's easy to just return anywhere. But let's keep this simple. Let's add a variable while let's do found all equals false, while not found all. Found all bad chars, right? We use this variable 3 times. Why not have a long name that actually says found all bad chars? Well, not found all bad chars. And then here we're going to set it, but we're going to do a test first. So this will also be an elif. And the test will be if we are actually at the end of all the characters and we didn't find a bad one. So
Honey
if we're at
Moore
this.
says, hello, ma'am.
Hello, welcome in. So we're making a automated buffer overflow making script here. So if the length of this is equal to, actually the length of this -1. And let's do it the other way around. If I is the length, so I will repeat from 0 to length -1 because it starts at 0. So that's why we need the -1 there. Then we're gonna actually test that this is true, like I said, because I don't assume I know stuff. And we're gonna print the length. Actually, let's do this for let's print something else. So just checked the last char, and it was okay, right? Because if it wasn't okay, it would have hopped in here, right? And these we're gonna actually not print here, but we're gonna do a print before the if, so we will always see it in every step of the loop. And we're gonna print both of these. It's supposed to be an F, not a G. It's just me not finding stuff on my keyboard. So an I is not a string, so we need to convert it to a string because it's an integer. Equals this. And oopsie. Wrong character again. And the length is also not a string. So we need to convert that too. And bird wings again. And then we're gonna actually set the response there too. So we know if this is true or not. And it will also be maths. Or Boolean comparison. So we're gonna check this test here. So, oopsie. That's interesting. I Control-Shift-C, and apparently, interesting. It's just fun to find new features. I'm like totally lost. What was I doing? I think I copied it. Let's see. So this Boolean comparison should give us a true or false, and let's do a -1 in text there, and this is actually an equal. So we want to know what this is. This Boolean comparison, what is it? And it should be false all the way, and we're going to get a lot of output now. I'm sorry, but debugging. So it worked, but why is it? Yeah, so let's abort it because I didn't set anything, right? I just wrote found but all cars. I didn't do equals true. So we really don't have to have an else if here. Yeah, we do, because the last one, the last one can be bad, but if it is, it's already added to bad chars. So we don't need to worry about it. Yeah, so we don't need an elif, because it will still be done in all cases. Yeah, so when a character is added, I'm messing it up for myself. So this will be printed out all the times. If we do it here, it will break out. This is just the break for the loop, where we found all the bad characters. And what I didn't do before, so it said here, checked all the characters, it was okay, but I didn't set it to exit. So I half wrote a line. So now we should do it 1, 2 times, and then it's finished. And it's got all the bad characters. Only we should print it in a prettier way, right? So this print of the bad characters is not as pretty as the other one. Current bad characters plus. So I do have a scroll bar somewhere, do I? Whatever, let's just hop. So we need the pretty version. So I'm gonna rerun it. So we have our two fake ones being added, and then it exits. And we can see that it doesn't skip any characters, right? So at the last one, let's actually do a print there. I want to make absolutely certain, no problems, that I did this right. So we're gonna copy this line, and we're gonna do last one, and yeah, let's do, we have I already printed, right? Because we have it from there. So last one, 255 equals 255. Alright, yeah. So if we were to keep this one, I would have to edit this because it's actually equals, right? But we just did this to make sure we actually ended up on the last one. 255. So we got through all the data. Our loops did not miss any characters, anything. And we're gonna delete a few lines that are not good, not useful. Like this one, and this is just for seeing that we really loop through it all. And now it will look like this. So it found bad characters and found another bad character. We don't need the error lines either, right? So the error, bad data, we're gonna skip, and it will look like this. Testing for bad characters. New bad character, current bad character list. New bad character, current bad character list. Just check the last car and it was okay. Bad characters. And we got them all there. Meaning also we started with 2 as the already set ones. But we would have known that as we wrote edited this. Actually, that is a good thing to do, to actually add the bad characters further up in the script, as this is input data. Initial bad characters, right? So here we're going to make a new variable, initial bad shards, and we're going to put this equals this whole thing here. So I'm going to copy this to the end there, and then I'm going to delete most of it, this bit. So we just have this here, and then we're going to set this line up here. Null and possible characters from reading the program code, this is what the user of the script set, right? So also the context bits and stuff here, we don't really need to set these. We could read these. So change to read these from binary. So we needed to do here. And it made it blue. So we're done with this section too. Testing for bad characters automatically. Let's just clean it up a bit more. From the core dump, this is a long comment. Well, we don't need to print it all again. So, or bad data test, we can delete this, right? The question is, do I want this to be saved somewhere? No, we can redo this. And it was logical, and I hopefully remember the nice style there of ChatGPT to input it. So we have the string until the 35th character, or rather -1, I guess it is. Yeah. And then from the 36th one. This is a quirky thing in... I mean, 34 there and 36 would have been logical. This would be the 35th, right? But that's not how it works in Python. It's a bit odd. That's why I checked the loop for the range X in the same way. It's yeah, it's because of the zeros, I guess. So also we fit this code in one page. This is nice. So we could make this into functions later. We might. Let's remove the exit. We have our bad characters, and those are what we need for the next step. It's already finished. So we're going to encode the shellcode now to avoid bad characters. And encoded shellcode equals encode shellcode, avoid bad chars. Kind of simple, right? Encoded shellcode. Well, now we print the shellcode and the new shellcode length too. And then I'm thinking we'll add an exit here and run this as a test, just to test the bit we have finished. So, testing for bad characters, encoding shellcode to avoid bad characters. And now we can see this shouldn't have any double zeros, it shouldn't have any 46s. And it already didn't from the start, so we didn't need to encode it. It is the same. It's also 57 again. So if we would have done this with the previous script, it would have added length here, because I've tested. I've added 0x. Well, let's do it. So let's make sure and double check. We always want to confirm stuff, right? So let's add another one here. So \x01 is also a bad character. This is also a test that the order of these doesn't matter, right? So if we run this now, I just want to make sure I saved it. So now when we do it, we get what? We do have 0-1s here. So they might need to be ordered. And they are not, because we're just appending to this text. That's interesting. But it is a funny feature of this. Let's actually print the bad chars closer to where it is. So we're using the initial bad chars here. I marked it so we can find it easily. And then bad chars is what we use. We add to it. Found all bad chars equals true. It's also bad chars. Then we print the bad chars. We say to tell it to avoid the bad chars, right? So the bad chars that are printed just before here should be the ones sent into here. That they need to be sorted, I did not know. Let's see if that is the case by just changing the order of them. This is very good to know. If this is the case, you know, it is an odd thing. So, even though we would usually do this, if we automate it and we put like an F here and then we generate the automatic characters, it's a very odd thing. So now it didn't remove the 0-1s. Why? So I did this before and it worked. Is the format correct? Did I do something odd here? So encoded shellcode, not shellcode, is what's printed. And we should low length as a new shellcode. And the bad shards is the updated one that we're printing just above. So let's debug this. Very nice if we found this problem. Or we would have had problems later when we weren't thinking about it. So bad shards, let's do like QWERTY here, right? And also nothing else. Let's just add a lot of characters. Well, maybe I shouldn't duplicate them. If we put all letters in here, we should have something that differs, right? Don't you think so? We can do all the numbers too, right? This is a lot of bad shards. I'm thinking it will say I want to bytes. Okay? That's what I'm assuming, but it might take this. It did, and it didn't change anything. So what if we byteify this thing? So just B it. B. We don't have to convert, it's just a string. So now we got an error. Avoid B function. No encoders in E386 we can avoid for. Okay. So this is a limitation in the library. The question is, how did we get this? Let's put our code there, our actual data. This. So actual data test instead of long. So we have uppercase F, we have these two. And let's run it. Yeah, now it did it. So there is some kind of odd thing happening between this and the input is not coming through. So it is a formatting problem of this data. It is supposed to be bytes. It's getting the right format, but still it doesn't do it. Because if we do it here, it works. So what if I make a string of it? We're making a string of it. We looking at it. And then we get the wrong thing. So this is probably our problem. That our bad shards is not bytes. And that we can fix very easily. So let's just undo until we have our variable name there, because that's the easiest way. And then we just bytes this. And we add the comma. Do we remember? Latin 1. Oh, I'm blind. Latin 1. Where are you there? Latin 1. I'm looking for white text and it's orange. So Latin 1. Learning to remember that one. So saving, running, and it's fixed. So this is because we made a new variable, and that's what we used instead of having just typing fixed data there. So good. it all works. Did we put any debug stuff? Yes, we did. What we were going to test, and we want to finish testing, is if the order of these matters. And now I don't think it does. I think that was another bug. I just entered it like this to make sure that it worked. Right? So now it should still work. And now when we remove, we can see if it's in the wrong order here. So it's the same right data. If we remove this one now, it will not need to encode it. There. It did it anyway. Right, so 46 was in there. Do we have 46 in here? Yeah, we do. 46 is there. So it needed to encode it. I just thought it wasn't because it didn't do it. So it actually needed to encode it. That's good. Right, so now we have another step finished, which means we only have one more step to do. Then we are finished all the way with making an automatic generation of the string we need to input into this executable on the machine, on the box, BrainPen 1. And it will be reusable for other cases like this. Automatically. So we're gonna find an address. How do we find an address? So what have I got here? Yeah, we can print the functions, but I don't think it's in there. I don't even know if it is, like, how would I find this? How would I find this? Should we Google?
Superimposer says.
Ah, what a day. How is your going, Sophia?
Yeah, it's doing great. We're like on the last step, which is probably the most complicated step, though, of making an automatic, like, buffer overflow maker for Linux UI binary. So it is nice. But we need to fix the last step, the last challenge. Let's actually make a new one of these here. So it accepts equals
nice.
plus
you are
address.
One step to pwn the world with one click. D.
Yeah. Well, for just UITs on Linux, you know. So it's not for everything. But as the files here are Linux only, as we can't
Linux
run
rule the
executables in R2. But Windows ones might be easier to do in other ways. So this was the kind of one that I was the least understanding of, I think. So if we look at how I would do this manually, I would search in how would we do this if we were using R2 or GDB? How would we search for an instruction? In what would we search, right? Because if we were using the last one, we actually used Mona to find it for us. Instead of having to like search in the graphical interface debugger or having to do something else. And that was a Windows one. So I have done these, and I did have my notes up, but I closed them. So let's see, maybe we should open them up again. By the way, we can copy the latest version of the code to the notes because it's kind of updated now. So there. It looks prettier here, right? And it's all purple. Examples for buffer overflows that I've previously done. I've saved them as examples. Why do I have Windows up? Yeah, I know why. Yeah, I should look more at that. So
Purple in the new
buffer
grey
overflow.
hat, isn't it?
Maybe it is. I don't know. I guess not, right? Because
Is?
I have it purple. And I'm very, very nice to everybody, right? So I don't even want to be bad to bad people. I think that if you're good to bad people, they become good people. So what are you working on now? What are you doing? Examples. Overflow 3 Seaweed binary. So in this one, how did I find that one? I didn't. Right. So this one was I used my old technique. And I didn't find an instruction in this one. So we're back to finding a good strategy, finding a hole in my buffer overflow strategy and making it better. I think I have done this, but I'm not 2000% sure. Just like 99.9.
I was referring about the purple team, is kinda like the grey hat of white hats, D.
Okay. Yeah, purple team, like red and blue combined. So I wonder when I did this. I remember I had odd intermittent errors and I added knobs, a lot of knobs, and I managed to get it to run, but it wasn't like pretty. And what I'm doing here is I'm actually putting the address, which we could do. We can do this easily because it is easily printed. So let's do a first test. What we could do is just to get the SP, right? We could just put
Me. Oh, I'm going
SP.
crazy because in my country I can't have a Google Voice phone number, and I have a potential client on Telegram, but I won't create an account with my real phone number, so I have to find an alternative. D.
Well, why don't you just get a free SIM card from something? Can't you do that? Get like, or just buy a SIM card and use that to register, and then you're like, oh, whatever with that card. Easy solved. We could just put as the crash. Let's say core file. What's the variable name? P core file SP. SP value. Value. It fails already. Value into EIP. Into the EIP position. Position. But let's for basic ones, for basic buffs. Bullets.
Every SIM card in Italy have to be registered to the name of the user, for security reasons, they say. I was thinking to get a virtual SIM somewhere else, but I have to see what are the most reliable and secure I can find.
Okay. So you can't get around it. Interesting. But let's try to find a GMP or other useful instruction to use to hop there. And I have gotten else executable for some reason. I don't know why, but probably because I didn't know that I already had this data.
Because I won't do anything DivSec related with my personal information. Call me paranoid, but better safe than sorry, right?
Yeah, I just think it's I guess it's good security in Italy then, but still. So we can list the functions, and I already know there are no GMP ESP instructions. So I'm thinking I want to Google it, but mostly I want to let's give ChatGPT another challenge today. So I use pwntools to automatically. No, let's not give it too much information. It'll just flip out. I want to use pwntools with Python to find a JMP ESP or other function instruction or other set of instruction or other instruction, finding the instruction or other instruction or set of instructions that would give the same result in a Linux ELF. I will use this in my
I am trying to
buffer.
play with the R1 AI on my laptop. It is not that crazy, but seems pretty good, even the light version.
Oh.
Maybe not like Llama or GPT, but is not bad at all.
So I did actually try comparing ChatGPT and DeepSeek earlier today on making a CV. New CV for a specific job.
How it went?
Both gave me... I sent it the mail I got from the recruiter that contacted me about this one, and then I sent my old CV and I added my about of my LinkedIn. And it added skills, both the same, they were very similar, like extremely similar in the headers and everything. They had the same headers. The one had like education and certs, and one had education certs. That was like the only difference in the headers. There was some tiny ones, but they had like the same stuff. But both gave me skills I didn't have that were listed in the instruction or in the like job description, right? So have a proven experience with listing all the things it would be very good to have for this, but I didn't have, which is fun. So it's not like I read first. I first read DeepSeek's once, and I was like, "Oh yeah, this is not ethical." And then I was ChatGPT. Oh yeah, it's just that it can't.
AI already got it, lol.
Yeah, it was kind of like it did. I don't think it solved the difference in the texts, though I think it did, but it still didn't really get the thing with. Yeah, it should be used to making CVs by now. It should probably have done lots of millions of them, right? Hmm.
His crazy one South African rand is at a similar level than GPT with very less investment.
So the reason I'm putting the CTF there is I don't want it to give me too much information. It won't complain. It never told me this is not ethical or you have to be ethical or any of those things. Or not answered, ever. Yeah. So, someone said, you remember how big the Doom executable was? And what happened? And maybe the Chinese actually have to think and not just assume there's computer power. So great that someone does it then. But it's still the ethical problem, right? And as a Swede or Italian person, maybe we don't trust the US with our data either. But it's still a big difference with the Chinese. Just like democracy-wise, So I wouldn't just. I'm much more careful with my data.
I think the ethical concept
one.
is more a human concept of consciousness. I don't think AI will soon find any difference between ethics and non-ethical.
No, it's just that they say that if you search for these, I don't know the name in English for the like Chinese human disaster stuff, things that have happened. It just says it can't answer and stuff, so you can't get the full truth about some things. But if it's only that is a limitation, then as long as that's not your purpose, I understand if a Chinese person does this and they would give the correct answers, they would be like hit in the head with a hammer, so they couldn't. So I'm sure the people who made it don't have the odd opinions, probably, but they live in this country where they have certain rules they can't bend. But I'm not going political here on stream.
You mean they probably censors some subject?
Yeah, they probably have to censor stuff because of where they are, right? Because otherwise they couldn't continue doing it. And they wouldn't, yeah. Probably worse than that too. Yeah.
Yeah, it seems probable.
So, well, we'll see what happens. The more cool AI stuff or LLM stuff there is, you know, and from all the different countries, all the research, and people with limitations having to push the edges, push down the size of stuff, push down how much. You know, that's what brings new evolution of stuff, right? If you can't just, it's like you won't try and find a cheap
We'll see.
car if you
For
have
now, I'm
infinite
stay
money.
with Llama, even if I don't like RoboZook.
So using local LMs on your machine, because I've been thinking of which one to try out for myself at home. So of course my computer is not that new. I have like an old one. Let's see. So system. This is my computer. I have a 7th gen i7. It is not the best thing ever, you know. I even installed it 21, so it's 4 years since I installed the machine. I really need to redo it. Also means I bought it then. Used. I buy used stuff because it's stupid not to. Not efficient. You can use pwntools to search for an JMP ESP instruction or equivalent in a Linux ELF binary using the ROP module. Yeah, so we read a bit about the ROP module, but as I don't know a lot about it, I thought I'd cheat, if that's what you call it. Gain knowledge in a more efficient way. So, cheating and being efficient is often the same thing, as long as it's not actually cheating, right? ROP module, or by manually disassembling sections of the binary. So we've manually disassembled the sections of the binary already, and there's nothing there. So that's it might not be possible, but we want to explore all the options here, right? So if we don't find anything, we have a fallback option of just putting the SP value in there. So that could be the fallback if we don't find any instructions. Because that would just give EAP hop to the next instruction after where it was popped from. And next position. And this is what we want to do, but we wanted to hop to a place in the executable where it's actually like meant to be executable stuff. I guess it's still hopping back to memory that's not supposed to be executed. So, if it's safe, it wouldn't still work, right? ELF equals ELF vulnerable binary. Replace with your ELF binary. ROP ELF. Looking for jump ESP or equivalent. Next, ELF search ASM jump ESP. And this will assemble and give us the machine code for jump ESP. Yeah, this is a very short and nice code. Alternative, adding gadgets that achieve the same effect. If jump ESP isn't found, you can look for equivalent instructions like call ESP, ret, useful for ret to shellcode techniques. Yeah, so we can push ESP ret. We can't do. So we could add that to the search here instead. So we have 3. Let's actually put this as code into our notes or into our script really. So this is the new one. So ELF ROP. Well, I guess ELF. So what have I called it before? So we're currently using P for the process, and we have a connection here, and I know that some things we might not be able to get this way, but we have to run the elf function. So I guess I was going here. So here we have the E equals elf. I used E here too. So this is the exploit we use to get to the machine when we're finished with this. So that's why I have this one up too. Let's hop back down. And 17, 13. I do have an anti-siphon training in a bit, and I'm actually going to put up. Should I open Twitch? My toe is squished.
Way better than Brave that freeze every time I open Twitch, lol.
Was there a try? So you tried to run the DeepSeek. Is that it? This one that I have up here that you can't see because you weren't on the screen. Is this what you did? I'm gonna switch mics.
Yes, DeepSeek R1 Lite.
Okay, so how do you do it? How do you get started? And you can please tell me while I'm frying some hot dogs quickly. So now you can still hear me with the thing in my ear. I'll be right back.
Hear you. I'm
Great,
searching
great.
the guide I've used to install it, because
cool,
as usual
cool.
I didn't take notes of the process, lol.
Okay, so you just went for it. So I'm always thinking of when I learn something, I want to be able to teach others too, you know? So that's why I make notes so much. And also to remember what I was doing if I want to do it again. So I'm just gonna...
Here is the link, web
Oh,
link.
cool. Thank you. So that's an instruction for installing R1 on a
I
normal
use Lolama
PC.
to install.
PR Mechatronics says.
Cool.
Thank you asking, I'm still waiting. In 2 days I'll be able to send applications to college again. I'm sending them for the 20th time, anniversary. I've already bought whiskey and Coca-Cola. XTD.
Okay. Yeah, I guess, I don't know if I should congratulate you on that, VR, but since you seem to be doing it, I'll do it. So congratulations on the 20th anniversary. There? Yeah, so you're doing it in Ubuntu. Okay, yeah, so maybe you should just dedicate a computer to it, like an older one. But I don't know, because this is the best GPU I have on this one, 1080. We'll see. So I will read this, thank you, and we can test it out. But my main OS is Windows on my best computer, so maybe I should look for a Windows one.
Superimposer says.
I've adapted the guide for Arch, but it was only a test of curiosity.
Yeah. So yeah. We'll see what I do. Let's actually get.
I think if I ever decide to go the DeepSeek way, maybe I'll do it in a better way.
Oh, yeah. I'm just hopping into someone's Twitch channel to see if they hop online, because then we can read them at the end of stream. Otherwise, I know the time that I should have Come on. 17:31. So we should have 30 minutes, and it's not like I have to hurry.
On a
So,
server, with Podman or Docker, and with a proper setup.
yeah. Yes, I'm thinking. I should really.
If
I
I
have
find a
several
cheap enough
computers here.
server, obviously lol.
I'm mostly thinking my old PCs. So I have several old machines, and they work in different levels. So one has a dead motherboard. That's kind of like not that one. Um, but that's the one I was thinking of ordering a cheap one off AliExpress to see if it works with the processor. Then I also know if it's a processor or if it's a motherboard that's broken, and that's an X99, so it's a good one. If it works, it's might be better than the high one I have now, even if it's a China board.
How dead? Dead is the motherboard. Have you checked it?
So it is so dead that if I connect a power supply, there's nothing. There's no action at all in any way at all. But that dead. And I of course tested with several power supplies. So uh, yeah, let's try this code now before we end for today. Because the anti-siphon course, which is pay what you can, meaning you can do it for free. It's very nice, and it's a great atmosphere in there, and yeah, it's just great. They were also talking about certificate this time,
So not a BIOS
so I'm very
problem but more
curious.
A for the trash bin problem. Got it.
Yeah. So, or fix hardware. If you can't find a problem, I don't think there's anything invisible on it though. So what broke and how, and can I fix it? And I'm a bit curious actually to go that far into looking at it. I'm a bit curious to debug the actual motherboard. We'll see. We'll see. So we have this from ChatGPT. We have Elf, which we already have the code for this. I
Maybe you
copied
find a
this
cheap
line. I didn't copy
substitute on
this.
eBay.
Yes, I found cheap ones on AliExpress. So that was the thought. So let's hop this in here too. And actually, I'm going to well, let's keep the elf then, I guess. But I've used E before, so let's not do it. It's nice to be consequent because when you're typing later, it's suddenly like, oh, I typed the wrong thing. So ROP E is ROP. Jump ESP is next. E search as jump ESP. And we don't really need to run the rest of the script to get this, but as it is in the script, so address is what I call the one I want, just to make the rest of the script work here. I don't know why I did this. I'm just going to go up. Yeah, that was also old, right? All shores John argument. So argument. This is the old argument here. So we want to replace this for this. So the only reason I used cyclic string instead of just ace was there was different ways to find this data here. So maybe I should change it. But there was one to find match the cyclic string, but we're just using SP here. And if there's something I say that you don't understand, you should ask, right? I've been talking about this a lot now, so I'm like also speeding a bit because the stream is about to. Time is running out. I would like to continue forever, but time flies, unfortunately. So, elf. I'm kind of thinking this won't find anything because I have checked manually using this. And now, let's just run it and see. Actually, I'm going to put an exit here because I like
It is
knowing
probably
where
my
my
fault that I let you
script
change
ends.
focus. I'm sorry for it.
No, I don't. Not at all. I'm happy to get information that I asked for. So thank you very much. And
Less
also,
than
I could
3.
actually chat about it while making the hot dogs, right? Uh, so in module next, stop iteration. Yeah. So we should probably do this with a try. As stop iteration, I'm assuming it didn't find it, right? And it can't return an address, and then it's like broken. So let's do the same with other instructions. I believe that we could use a semicolon. So let's comment this one. Let's make a new one, exactly the same line, but we're gonna change jump to column. So call, and then we're not gonna find this. I did save it. Let's just double check. So stop iteration. I'm assuming stop iteration means there's no instruction, right? And I'm kind of assuming we're supposed to do this more basic way for this one. And what was the last one I was gonna do with the rat? It's in my notes. If you know other versions of this, you can help. That's very nice. So I don't know where in my buffer also notes I would have this. That's a basic, because I think it's like somewhere where it's not logically supposed to be. It's like instructions that it's just push ESP ret, is it? Let's just try my, and I don't know if even we can do this. And should we use a semicolon there? Because that might comment instead of, but I've seen it done like that. But we just wanted to make it assembler from these. I think it will translate it okay like this. I don't think it ever works. I don't think we'll find it. And even we got another problem, right? Because this is not correct. Yeah. So if we add a semicolon here, just because I happen to have seen that sometime, yeah, then we got the correct error message. But I don't know if it searched for push ESP or push ESP ret. That was just me thinking logically about it with the push ESP. I didn't really remember, but if we're gonna put the value of ESP, well, the address really, right? Yeah, that might be totally off. So exploring memory, steps to exploit a buffer overflow. Is there a buffer overflow? Fuzzing, shaking position of saved instruction pointer stack. Find bad characters. Finding a return instruction. And there we have push ESP rat, meaning I did remember it correctly, right? And with R2, we can do this. Let's do these in R2 and see if R2 can't find it, it doesn't exist. And if these all crash, um, uh, if none of these work, equals, oopsie, I do that sometimes, I was supposed to do that, equals, use, just put p dot core file dot sp and pass the address. I'm kind of assuming that's what we're supposed to do with this one. Oh my goodness. I haven't found any instructions when I manually searched right here. And we can functions, e functions values. Now we use e just as it was before there. So here's all of the code. It's not much. It's a tiny program. That's why we can't see a lot. So if we R2 this, and this is actually, yeah, let's keep this one. But Control A dash A, and it's analyzing stuff too. And then I guess we DC it. We get a crash. And the current address there is 42, meaning it did crash, it did get the bees. I don't care about the rest of the data. For now, I just want to do a JMP ESP. And let me do a call ESP. And let me do a push ESP rat. Okay. Well, so we can do like PDF at main to check out the main. We can do that with all the others. We can check out, is it AFL? I don't know why it keeps hopping up to the top. So AFL, this must be wrong, is it? No, it is right. It's just had crazy much things. So we check out all of this and read all the assembler, and we still probably wouldn't find that.
VR Mechatronics says, I just offered to apply again and send that diploma from SDU to the High School for English A, XDDD.
I don't know what SU is, but go for it, apply and stuff.
This one form GPT-4.
Did you make a diploma? The one you made one, right? So let's just PDF it main, just to look at what R2 looks like if someone in chat didn't see. It's kind of nice with the colors and everything, and we get nice comments. But we don't find any of the instructions, but they're not here, right? So R2 didn't find it either, which makes me think it's not there. And we can find another one to test the script on. We have like 15 minutes to finish the whole thing. Can. And the only thing we need to do really,
Web link.
add, try, and ifs for this. So I'm not gonna keep this in here because it's not interesting. What we're gonna do is to just put p core file sp here, and I'm thinking, oh, this was interesting. We probably need to get this address converted now, right? Or I know we do. It will not automatically switch the order, but I'm sure the pwntools has a tip for this. And as we are limited on time, I'm not going to check the docs, but I'm going to use core file.sp as the address. Please help me fix the endianness. I'm missing letters. Endianness. Whatever. For it. So quick. I'm sure it already remembers pwntools, right? We don't have to say that. Core.sp, hex p32. So we do p32 on
Right,
it.
also open Canvas, then you'd be able to edit code.
Yeah, but I don't want to. But thank you. So when I made the CV thing, it opened this thing. I don't really like it. Sorry. You know, I'm a command line person, not a GUI person. I can use GUIs when they're better, of course. I just haven't seen a use for it yet, as I wasn't really thinking I just copied stuff into my own Google Docs, and most of what it said was not good. So we have the core dump already. We also have SP. We just need to run p32. We can actually steal its comment there too. So we're gonna use p core file sp, and this won't needs to be using the oh my god, my nose. Need to be using 3264 bits. I couldn't type when I was sneezing, that's odd. Depending on, well, it's up there somewhere. I'm not gonna look now because we have limited time. Address p32 p core file sp, and this should be the address used in our payload. Oh my goodness. And it should actually be, I think EIP position is still what I use. That was commented, right? EIP position. Then you use yeah, I'm kind of thinking it's prettier to use ACE when we send the payload because it's easier to see in the memory if we were to need that. So the actual address now. And then we're going to send our encoded shellcode plus. And this is like nostalgic almost. We're not finished because we need to fix this into actual working code. Better flexible for other possibilities. But we have address length times b cycle string. Yeah, that's not useful. So a times EIP position plus address plus encoded shellcode. And now we print it. Do 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 do. Will it work? Will we have time? We have 8 minutes. We won't have time, will we? Yeah, so in one way, I do feel it would be sad to rush through this last bit of the box BrainPen 1 when we've been really patient and waiting for all the learning that we've done with pwntools and not just rushing through it, grabbing the payload, getting the SP and doing this earlier. But I'm also very curious. So this will have to wait for tomorrow now. And tomorrow I also have 2 car checks. So I'm going to check mine and my mom's car for the yearly checking. And hers is 12:40. So I might start streaming earlier than today actually. We'll see. It depends on the kids too. But I work in the morning. So wait, should we fix this then? Because I won't have time. Let's check the output, right? If it looks good. Did I already print the SP? And this will be an else. Else, right? Yeah, I was like, what did I have copied? We're gonna print this, which will look horrible. And we also gonna need to pretty print the using this. All output we want it to be \x. So payload. Instead we did badger to the payload. So this is a full payload we send with Python. And we could let it just do the printable characters. But I'm kind of wanting to see all of the details. And it's easier to see it when we do this. And the core file is an address. So let's put one of the address, copy one of the address prints. Yeah, it is the same as the crash string. So I'm just thinking this is least editing of the text. So down. So
John says
SP.
Neolimyspace says.
Fix it 42 wave.
VR
Hi.
Mechatronics says. You know what's weird? Today I read an article about Bravikiki had 77 people and they allowed him to do master in prison, but he say no, refused, and I'm free and they refuses me 19 years. John says
Oh,
Neovimus high.
yeah, I guess it's a lot of you know, media presence. People know about it. But that's still very, very, very crazy. Uh, yeah. So there. Let's do this format for address for exploit, and then we go the address instead. Now we will see the endianness should be reversed here, but I want to know that this function that ChatGPT gave us works, right? And we won't have time for much more because
John
it's
says
3
Neovimus
minutes.
says.
In and out, cleaning the house lol.
Uh, okay, clean the house. So let's quit this. Let's run our exploit generator. And integer is required. So address is then in what format? We plus it.
Working on a project or a hack?
This is a track me box called Brain Pan, but we're taking the opportunity. So I've spent a lot of streams now exploring pwntools for Python. So we're learning all the quirks and niceness we can learn from it. Yeah, so it's bytes. Oopsie. So let's str it. So it goes through all the steps of generating an exploit here, but we haven't been able to find any instructions to jump to. So we're going to use just the ESP value because that's where the code is. All right. What? Where? What line? 188. Oh, no? But it's doing Latin 1. So I'm just quickly trying to fix the last bit here so we get some output data, but let's put an exit here. So we're not ready yet. We will have to accept that we won't have time to do it all in a few minutes. This is just to confirm that oh, that's not right. D space D. Yeah. So we wanted to write it in a better way than this, but it's okay. It's just that it happened to be 20 is space, 44 is D or 44, and then it can't find characters for these, so it prints them like this. So it's reversing the endianness nicely. So it's ready for sending. The only thing is that I copied the wrong code for this. I don't know why I did that though. Let's just print payload. And we can fix the niceties next time. So there we have the full, hopefully functioning thing to send with Python to as a argument to get the last stuff of the brain pan here. So let's see how these guys started. They have. So we're gonna read on the siphon and see if it works. Let's hope it does. Yeah, so it says subscriber only chat, but they use their Discord as a chat. So hop into their Discord. And thank you everybody for being here. Thank you very much. I don't know why it says subscriber. Oh, follower or subscriber only chat. It's follower only probably. So just follow and you can chat. So thank you very much for today. And we'll do the last bit tomorrow, right? Well, the last bit. It's never a last bit on learning things. I want to explore pwntools more for sure. So
Superimposer says.
Yeah, see you.
See you, Sophia.
And thank
Take
you
care,
everybody for
less than
being
3.
here
Honey to
and
Ham
learning
says.
together with me. It's
and
fun.
best love.
Yeah. So let's check their cool educational. This is actually 4 hours now. From now until 22 my time. So they're doing lots of cool labs where you can learn stuff. So if you haven't done all the labs, do it. Bye bye. Thanks again.